Good evening. My name is Eric Gradman. I am the CTO and mad inventor at 2-Bit Circus. Now, ordinarily, I do actually have a bright red mohawk. The terrible weather that Bill Pierce was mentioning beforehand, I encountered that on the way over here. A windstorm just knocked it over. Actually, I'm in disguise tonight. So the reason I'm here tonight is I want to tell you about a project called Data Painting with the Intel Galileo. And this is a project that we did in partnership, we meaning 2-Bit Circus, we did in partnership with Intel. So why did we do this project with Intel? Well, we like to make fun learning experiences at 2-Bit Circus. And you see, it's no longer enough to merely teach kids to program on computers. We need to teach them to program on computers, and we need to get them comfortable with electronics. Because in the future, programming might not be enough. You have to have some level of comfort with Internet of Things devices and cloud computing and electronics. So what is this kit all about? This kit is all about combining Intel Galileo as a piece of hardware and software in order to allow completely new, never programmed before, usually middle schoolers, to experience what it's like to play with some hardware and to play with some programming. We're not creating masterpieces here. We're not creating sophisticated pieces of software. We're going to make art with electronics. Now, this project was all about bringing learning and joy to kids. But this presentation is designed to shock you. And it's going to shock you for one of three reasons. One, we're going to talk about electronics. Maybe that's not going to shock all of you. I realize it's 2015. Two, we're going to talk about visual programming. Now, I don't mean to insult any of you with the first two. If none of those got your hackles up, we are going to use the eval statement. Cue the gasp. Yeah, there we go. That's what I wanted to hear. All right, so first, let's start off with what the Intel Galileo is. The Intel Galileo is both the bigger and older brother of the Intel Edison. It is a little bit slower. It is a little bit more power hungry. It is a little bit tinier in every dimension except for its geometry. It's bigger than the Intel Edison. It has some advantages, though. Why might you choose this over another device? Well, the answer is the Galileo is kind of Intel's answer to the Arduino. So you can take your existing Arduino shields and you can plug them right there into the top. It's got that, that very familiar pinout pattern that's familiar to anybody who's done Arduino programming. Also, you can take your existing sketches and you can run them. Right? And you might do that for some time. And then you realize, holy cow, inside that board is running full Linux, running node.js. I don't need to go into that anymore because Bill has already told you about all that. Everything he said about the Edison pretty much applies to the Galileo. So what do? We took this device and we hooked up some very simple input-output devices. Actually, we just hooked up input devices. This right here is a potentiometer slider. So you can move that thing up and down, and it changes an analog voltage. That right there is a touch sensor. That right there is a button. That right there is a light sensor. Now they're all plugged into this shield here that makes it very easy to prototype with devices. You can hook up servos to this shield. It's made by DF Robot. You can hook up these pre-made sliders, these pre-made devices. Real simple. The point is, the kit that we are distributing alongside Intel includes this shield, and it includes all of these little devices. So it makes it really easy to set up. And then we let kids program with those devices. So what is this on the right? This is Google Blockly. Now, Google Blockly is a programming language. It's a visual programming language that runs in your browser. And it is relevant because it is totally written in JavaScript. And if you're going to make your own language with it, you are writing in JavaScript. So what does this program do? Well, this is a sequence of actions. Move forward, turn left, repeat until something. Do this thing, turn right. It's Logo. Everybody remember Logo? Well, someone has gone to the trouble of designing these little blocks in such a way that not only can they be snapped together in a meaningful way, but they can be converted into code that will do something over here. Now, something is sort of a function of your application, right? This is a domain-specific visual language on the right, and this is some kind of maze thing on the left that visual language is meant to automate. So it's worth reinforcing the fact that if you're working with Google Blockly, you are working with a domain-specific language. And so as a visual programming language designer, you got to figure out what that language is. In our case, we decided to make a visual programming language to tie together the GPIO on the Intel Galileo, the potentiometers, the buttons, the light sensors, all those input devices, and fabric.js, which is a canvas library for making beautiful graphics. Don't worry, we're not going to be making any beautiful graphics tonight. We're going to be making crappy graphics, like this one. On the left here, you can see a simple an incarnation of that very simple domain-specific language that I've built. And on the right, its product, which is a rectangle, a red rectangle, rotated in space. I do love red. Those of you who know me know that most of my career has been spent giving about-to-fail demos live on stage. Let this be no exception. Let's give it a shot.
How many goats did you sacrifice?
I have a whole farm. Okay, so why don't I make this a little bigger? Do I dare reload the page? No. Who am I kidding? Okay, so on the left here, you can see that I have various, is this font size big enough? Anybody? Yeah, it's decent? Okay, cool. So on the left here, you can see that I have various Google Blockly blocks. Now, we have a rectangle up here, we have an ellipse, we have an image, we have a property. Well, let's start by putting a rectangle into our canvas. I've just put my first statement into the world. The consequence of that statement is that a rectangle has appeared on the right. Maybe we can change its color. Great. We can move it around, we can scale it, we can do all the sorts of things that you get for free with Fabric. Fabric lets us do that automatically. But now we want to connect that object that we've just created to some kind of GPIO that's connected to the device. That photograph I showed you, I have that piece of hardware sitting up here. And so what I'm going to do is I'm going to connect properties of that rectangle to the inputs that I have here. Well, how do I do that? Well, I'm going to connect a property driver, I call it, to that rectangle. Well, let's see. Which property do we want to animate? We have some choices. I'm going to animate its x-coordinate. All right, now I have some inputs. Well, hey, I've got some inputs that aren't, some sources of x-coordinates, some sources of data that are not, in fact, connected to the Galileo. Let's start by putting a sine wave up here. Oh, hey, look at that. It's going back and forth. Kind of cool. All right, let's drive a different property. I'm going to add another property driver. And now I'm going to animate its change in y position. That means how far it will deflect from its initial position that I set. To that, I will connect an analog input. Which analog input do I want to connect? How about A1, which I believe is the slider. And indeed, I can now move that from 0 to 1. Now those coordinates are in screen coordinates, which is why you're like, well, I can make it fall off the bottom of the screen, because it's moving one full screen height from its resting coordinate. Well, let's say I don't want that. I can change the minimum value of A1. I can remap it to negative 0.75 and remap the maximum coordinate to 0.75. I'll tell you what, why don't I change this to negative 0.25? And that will cause it to, I believe, go from the top to the bottom of the screen. Just like that. All right, well, let's see. What else can I animate? I'm going to attach a, how about a color? Blend between red and blue in a particular ratio. What should I connect that to? I'm going to connect that to a digital input. Well, that's weird, right? Digital inputs are either 1 or 0. So what does it mean to connect a digital input to something that's expecting a continuous range of values? Well, I can say that this digital input, I'm going to connect it to D2. That corresponds to one of the devices on this piece of hardware up here. It's going to go from 0 to 1, and it's going to take 1 second to do it. Come on, baby. There it goes. Right? So upon seeing a transition from 0 to 1, it's going to change its parameter and take a certain amount of time. Look, people don't want to press the button and have the thing just jump, right? They want some continuity. All right, I'm going to call that a successful demo. Let's go back to the... All right, so Look, we're at a JavaScript.LA meetup. You are all self-respecting programmers. You would never, ever program in a visual programming language. And frankly, with an exception I will mention later, I totally agree with you. Visual programming languages are hard to work with. You spend all your time working around their limitations. But let me tell you, designing visual programming languages is so much fun. The satisfaction that you get out of designing a really good API that you know someone else is going to use, imagine if you could get that and multiply it by the satisfaction you get when you see kids have fun with the stuff you make, right? It is such a cool thing to build a programming language, have kids walk up to the screen and program with it, having never done so before in their lives. It is really satisfying. So, highly recommend it. All right, let's take it down a little bit now. I'm going to put code up on the screen. And I don't give technical talks very often, so I always feel like this is a little bit like putting vacation photos on the screen, but bear with me. So up there in the upper right is a block. It's a Google Blockly block. This is the rectangle. When I put that rectangle block onto my programming environment, into my canvas, a rectangle showed up on the right side of the screen. Well, how did I make that block? What did I do to bring that block into existence? Well, you can see, right, I have a laser. I'm defining a rectangle block. It has an init function. I've set its color. That's that beautiful, I don't know what to call that. We'll call it 160. That's a good color name. So I can append a dummy input. A dummy input any input is something that has a row in this block. So a dummy input doesn't have anything on that side, whatever. It just says rect. This is a way of putting a label up. And then I'm going to append a statement input called properties. Now, what is a statement in Google Blockly's visual programming language? Well, a statement, it's the exact same thing as a statement in any ordinary programming language. It's basically a line or a sequence of lines of code that can be listed sequentially in a file. Print foo is a statement. If x equals 1, do this thing. That's a statement. All these things are statements, and they can appear sequentially in your code. And so this little pocket right there, labeled properties, so labeled because I named it properties, is a place into which you can insert stacks of statements. Now, those statements are themselves going to be blocks. Now, those statements must meet this criteria. They must, in this case, because I designed this block, they must be value setters. If you remember the demo a moment ago, those properties were a special kind of block that let me set the properties of the shape that I'd put into the canvas. So, for example, set the x position, set the y position, set the delta theta, set the theta, right? So I've designed another block, which we'll get to in a second, which has the type value setter. And only blocks of type value setter may be put into that properties box. Well, now I have a color, a pen field color, blah, 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 blah. We're going to color it, and we're going to make sure that what I plug into that block, that's a value right there. We're going to make sure that that's of type color. British people had some hand in this, and so it's a little difficult. Oh God, this is horrible. You can't read this. Well, look, here's a digital input pin. You saw me use this earlier, right? This is more of the same, basically. I'm appending an off value there. I'm appending a text input field. Now, once I've done this, this block comes into existence, and I can use it in my canvas. All right. Having blocks defined in the world is not enough. The whole point of having this visual programming language is that we can use it to generate code. Generate code. We're actually going to generate language code in JavaScript or Python or Dart or whatever language you care to generate it in. You write functions that take the blocks you've defined and output code. Now in this case, I'm generating JavaScript code. And so I literally have, and this is saying, this is the function that generates JavaScript for my rectangle block, right? I'm going to convert the properties that you saw earlier. I'm going to call this function called statement to code. That's going to recursively go down into all of those statement blocks. It's going to generate the code for them using the same method, right? And then I'm going to construct a block of JavaScript here. Now this is me very sloppily using some kind of templating library. I can't remember which it is. So it's going to call ensure shape on the block ID, it's going to begin shape, and then it's going to insert into that code all the JavaScript that was generated by this line. And so as you can see, I'm sort of recursively building up a program written in JavaScript. So for this very simple incarnation of the demo, which you saw, oh yeah, we're gonna basically right here. Every time the canvas is updated in any way, every time you drag and drop anything, right? It's basically going to generate at the top level the entire workspace. It's going to convert it to code. This is the generated code, right? Ensure shape. It's a rectangle. Begin the shape. We're going to drive its x property to get analog value, right? So somewhere else, which we'll get to in a second, analog values from this device are appearing somewhere in the code, and we're going to drive its x property. And the shape, which draws it to the screen. You know where this is going, isn't it? Don't you? You know. Take a deep breath, everybody. This is where we get to use eval. I don't know why it brings me such great joy to talk about eval, almost like I'm like stomping a kitten on stage. I don't think it actually shocks you as much as I think it does. Maybe in JavaScript, eval is much more widely accepted than. What could go wrong? Go to. Nothing. Nothing. All right. Every time that canvas is updated, in fact, every 25 milliseconds, right, it's going to reevaluate that code. So if the analog values from the hardware has changed, well, it's going to drive the properties of the canvas objects to a different value. And consequently, you see things moving across the screen. Now let's talk about where those data points come from. Where do those analog values, those digital values, where do they come from in my in-browser JavaScript code? Well, at some level, they're generated on this hardware, right? And they're shipped over the network to my browser. This is the function that's going to receive that, but let's see what's going on. Oh God, this is horrible. Oh, there we go. Yeah, that's fine. So meanwhile, on the server, right, we're using something called MRAA. Anybody recognize that? We just talked about that in the last presentation. MRAA is a library which lets you very easily capture input values from the hardware connected to your Galileo. And so buried deep inside this function, which is of far too small a font size, you can see that I'm creating these GPIO objects. This is a GPIO object for capturing digital data. This is an object capable of capturing analog data. And periodically, very fast, in fact, this update pin map business, we're going to read pins, right? We're going to read the value of this pin. We're going to read the value of this pin. And then we're going to ship that data. Oh, why did I put so much code in here? We're going to ship this data up over socket I/O. And the client is going to be reading this data consistently via socket I/O, updating its local map of what these hardware values are. And so in that way, with socket I/O and MRAA, we're able to expose every GPIO and analog input on this piece of hardware. We're able to ship it over at high speed over the network to your browser, which can then act on it however it likes. So we were here. Programming visually is no fun. And I made the claim that designing visual languages is awesome. Well, you know what? My lesson learned from this experience is that I actually enjoy programming visually in some very specific cases. One of those cases is this. I've been working on a different project, which is essentially a show control system for building interactive environments, interactive rooms. This system is programmed in Python. It's not programmed in JavaScript. When I write code for this, I write it in Python. But I'm working alongside creative people who are helping me design shows, right? We're making sure the lights go on at the right time. We're making sure that the interactive elements in my space, in the show we're producing, all happen at the right time, right? But when I want to change that stuff, when I want to change the timing in my show, I have to go into a Python file and I have to edit it and I have to reload it in my server, and that's a pain in the butt. Well, inspired by the experience of making a Google Blockly editing interface for middle schoolers, I decided to make a Google Blockly editor for my show control system. And so now what I'm doing, this is pretty much the same thing. I mean, I've created these fancy looking blocks, and I'm popping statements in here, and it has a similar structure to what we were doing in the Google block in the painting with Intel Galileo project, but it has a very different function. What's happening here is I'm generating Python code. I'm shipping that Python code up over a socket.io connection to a web server running in Python. And yes, I am running eval at some level on that code which is generated. But what this has enabled me to do is it's enabled me to collaborate alongside designers who aren't necessarily technical, who really don't want to be editing Python files in VI. Well, now they can write their own scripts. We can all modify one another's scripts. We can collaborate in this environment. And it is very, very cool. And it's kind of opened my eyes to the power of developing domain-specific visual languages. If you find yourselves working alongside non-technical people in a technical context, where it would be helpful if they were able to sort of prototype their own systems. Once upon a time, we'd ask people to write their own SQL queries, non-technical people to write their own SQL queries. Didn't work very well. But languages like this make it possible. Right? We're not generating SQL queries here. We're automating an entire environment. We're doing the lights and the sound and all that stuff. But it's really fun. It's really fun to be able to work alongside non-programmers and develop programming things. And there you go. That's data painting with Intel Galileo. Anybody have any questions? Yes, sir.
Can you reverse the process in that, for example, for the kids, the thing that you did before, if somebody wants to move the shape of the computer, can you command a light or something on the Galileo in the words that you want to speak?
Absolutely. So this project was intentionally constrained to be input is GPIO and analog, and output is art. Because, if you're turning on lights, then you're going to want to turn on motors too. And all of a sudden, motors burn out, lights burn out. We don't have to worry about this here. This stuff's going to keep working, and animated art, interactive art, is a medium that people can look at and share easily. They can take screenshots, they can share it with their friends. It's a very quick response time. So we intentionally chose not to do hardware outputs. Mm-hmm.
So this show that you're talking about, it sounds really interesting. What is that?
Oh, glad you asked, David. 2-Bit Circus has produced something called a story room. And this story room is a 1-hour adventure for 6 players, roughly 6 players. You show up and you spend an hour in this sequence of 3 rooms. In fact, you've been transported out of this environment. You are now in an abandoned science laboratory. The scientist who was working in this lab has gone missing, and it's your job to recreate his final experiment, identify his whereabouts, and we hope save the world. It's located downtown at our facility in the Brewery Arts Complex, and it is super high-tech and super fun. So if any of you are interested, 2bitcircus.com is where you can get the information on that. Any other questions? Yes, sir.
You're evaluating a lot of code every 25 milliseconds. How much can you put in there before you start to slow down?
Well, it's interesting. I don't know that there's any... I suppose it's possible for memory to leak, but I don't know why there would be any long-term performance implications of evaling code, as long as...
Are you evaling it every frame?
Oh, yeah. Yeah, I'm evaling it all the time. But evaling code should be no different than running code, at least in my mind. There should be no cumulative penalty to evaling stuff very fast.
Does it hit the JIT? Does eval code hit the...
Is that a euphemism for something?
The compiler,
Oh, probably not. But I'm running 5 lines of code. It's not a big deal, I guess. Hit the JIT. I'll have to use that in a sentence sometime this week. Yes, sir.
This is a smaller, idea. So I didn't see, obviously there's properties to be, manipulated, but I didn't see the box that we had, right? The actual position coordinates and all that, and when you move the box, you get to see the numbers change on the left-hand side of the screen, right?
No, you actually don't get to see the numbers change on the left-hand side of the screen. I think that would be a fantastic improvement. To me, something that's missing is sort of, is this thing on? Like if you've managed to connect it incorrectly, it would be nice to see some kind of debug output. Yeah, I think that should be in there, and it's not.
Yeah, it just like, I think it'd be good to see like some numbers on the screen, because we can see the graphical output, but we don't know what actual numbers are causing that graphical output.
Totally.
Yeah.
Totally.
Thank you.
Any more questions?